Okay, we're now going to do a Diffie-Hellman with small numbers, but first we'll do them with letters. Remind you how it works. And here's the setup. We've got Alice and Bob. Alice and Bob want to send, one of them wants to send the other one a message. And they can't just send the message. First, they're not in the same place, so they have to send it over the internet. But if they put it over the internet, it will be seen by others, particularly by Eve, who's a well-known eavesdropper and a general mischief maker, or an enemy, perhaps, indeed. So what are Alice and Bob going to do? They're going to encode the message in a way that can be decoded with the decoding key, but they can't send the key either. If they send a key, Eve will have the key as well. So that's no good. They have to come up with a clever way of each being able to generate the key, but without Eve being able to do it. And that's what Diffie-Hellman does for them. So let's look at how it works. They start by agreeing two numbers, a generator and a prime. Prime to prime, and the generator is any number. And when they agree these, everybody can see them, or at least you have to work on the assumption that everybody can see them. Probably not going to make them that public, but even if they just send them to each other, you have to work on the assumption that Eve's going to see them. So G and P are not secure. On the other hand, Alice and Bob each have his or her own number, which is secure. Alice's will be called A, and Bob will be called B. I think you can catch on to the naming convention here. Okay, so we've got a generator G, a prime P, Alice's private number A, and Bob's private number B. Everybody can see G and P. Alice can see A, but she can't see B. Bob can see B, but he can't see A. Eve can't see either A or B. But so Alice does the following computation. What she does is she takes the generator, the agreed generator, and raises it to her private number. And she mods that by the agreed prime. And that's what she sends. So she sends that, and Bob receives that. Okay, and Eve, of course, can see that as well. Bob, you won't be too surprised to hear, sends something very similar. He takes that same generator and he takes the same generator, but what he does is he raises it to his private number and he mods that by the same P. So those are the two things that have been sent. Okay. Now they are encoded now by these numbers, and Eve can see these numbers, but she can't from them get A or B. Alice can't get B, and Bob can't get A either at this point. But what they can do is the following. Alice can now take this, and she's going to do something else, which she's going to raise the whole thing she's going to raise what Bob sent her, and just to be clear that that's what she's starting, I'm just going to copy and paste. That's what Bob sent her. And she's going to raise that whole thing to the 8th power. So what's A? That's her secret number. So she's going to take the thing that's been sent her by Bob, and she's going to raise it to her secret number. Now, the reason that's really useful is because the way these things work, in this little bit of number theory, you can just take that exponential A and put it into the G here instead of over the whole thing. So what you get at that point is copy again. And so the A can come here. So I'm going to put that, and I'll make it BA, even though it's the odd way to write it, but it makes it clear that I've taken the B. Whoops. Those are dollar sign. Oh, the dollar signs come here. Okay. So what's happened here is that I've taken this A and put it in here. And what's going to happen with Bob is he's going to do almost the same thing. You can imagine. He's going to take the G to the A and he's going to raise that to the Bth power. And that's going to be the same as taking the Bth power within the A. So, okay. Okay, so there we go. Okay, so one of them's G to the BA mod P and one of them's GAB to the mod P. Those are the same, so they get the same number in the end. So that's the way it works. So they've got the same number, that's the key. Eve can't see these numbers. She can see this number, she can see this number, she can see this, but she can't see what happens if she raises this to the B. She doesn't have B. She can't see what happens if you raise this to the A. She doesn't have A. So Eve has no way of decoding it. So that's that. Now let's just do this quickly with numbers. Okay, we've got a public generator G and prime 23. Alice's secret number is 6 and Bob's is 15. Alice sends the number we computed before, which is going to be 5 to this. It's going to be 5 to the 6th mod 23. And by this computation, that's the same as 8. Okay, so she's going to send 8. Bob is going to send he's going to send 5 to the 9 to the 15. He's going to send 5 to the 15 mod 23. And that's going to be, whoops, 5 to the squirrely brackets. Where are the squirrely brackets? Okay, 5 to the 15 mod 23, and that actually turns out to be 19. Okay, and then so what does Alice decode? She takes the 19 she's got, she raises it to her private key, which is 6. Okay, she mods that by the prime, which is 23. And the answer she gets is 2. Okay, so what does Bob do? Okay, well, he takes a number he's received, which is 8. And he raises that to what power? He raises it to his private key, which is 15. He again mods it by 23. And that, you would not be surprised to hear, it also turns out to be 2. So they've got a secret key of 2 now. Their secret key is 2, and they can use that as a way of locking up their message. Okay. So I will see you at the next week. Okay. And I'll be I forgot that bracket again, but to be okay. Let's put it in. Just we're leaving all of this. Okay, so 19 to the 6th mod 23 turns out to be 2. 8 to the 15th mod 23 turns out to be 2. Turns out there's no coincidence there. They had to be the same. And so that's the key for the 2 of them. Okay, so that's Diffie-Hellman. And I see you next week.